Hello, welcome to our channel for probability and statistics. In this video, we will introduce coefficient of determination in linear regression. So the coefficient of determination, also called R-squared, is a value that represents or measures the proportion of a variability of the variable explained by the fitted model. So mathematically, R-squared is 1 minus SSE divided by SST. So where SSE called sum of error squares or error sum of squares is the sigma square of the y variable minus the y hat. Y hat is the fitted value. So this is the error term. Then take a square. Then sigma for all the observations. And SST is all the y value minus the y mean value, mean of y, then take a square, then take a sigma for all the observations. So if we look at this figure, it will be more clear. So this is the y bar. For the linear regression, all the y values has a mean value, y bar, right? And for this individual y, yi is an observation here. Then y hat is this point because this is the linear regression of fitted line. So on this point, for a given x, then this y value is y hat is the fitted y value. So observations minus this y hat is the error term. And observations minus this y bar is the deviation from the mean. So you can see from the formula for the determination of coefficient of determination, actually this range between yi and y mean value, then take square, then sum for all y observations is SST. And this part between the observations and the fitted line, then take a square, then sum for all the observations, this is SSE. So the coefficient of determination measures this part, right? If this part is very close to 1, so which means the error term will be very small. So which means all the observations, all the variance of the y, because y observation minus the mean value take a square is the variance, right? So all the y variance will be explained by this fitted line. So this is a very perfect model. But on the other side, if the error term is very big, only very small part of the variation for the y variables explained by the model. So it's a very bad model. So this figure shows two kinds of model. So this is the y bar, and the point is the y observations, and this is fitted line. So in this linear regression, R-squared will be very big, very large, almost close to 1. Because you can see the error term very small, the point is very close to its fitted line, which makes the error term very small. But on the other side, this figure shows a very low R-squared for the linear regression, because the point is very far from the fitted line, right? So coefficient of determination measures the variance of y variable determined by or explained by the fitted line in linear regression. But one thing is, this coefficient of determination will never decrease if you add more explanatory variable. So which means if you make the model very complex, you will increase this coefficient of determination. And actually, this is what we want, right? Because we can add many unrelated explanatory variable into the module. So this is called overfitting. So very important is that we may not arbitrarily focus on the coefficient of determination, although this coefficient measures the variation explained by the module, measures the explanation power of the module, but we cannot arbitrarily focus on only this coefficient by including more and more independent variables. So this is a balance between the model compactness, and this compactness based on the theory and based on the discipline in your subject, and based on the previous research by other people. So then we can add the most interesting variables into the module, then can measure this coefficient of determination. Then go this way, can compare between two models or among many different models. So this is only one part of the model measurement that we can use, not the only thing saying the model is better or worse, right? Thanks for watching.